Good morning, ma'am. This is Shivraj. Let's know about topic on Python below. Python Imagining Library is a free and open source additional library for a Python programming language that adds support for opening, manipulating, and saving many different image file formats. It's available for Windows, Mac, OS X, and Linux. The latest version of PIL is 1.1.7 was released in September 2009 and supports Python 1.5.2 to 2.7. Let's overview on Python Pillow. In today's digital world, we came across lot of digital images. In case we are looking and working with Python programming language, it provides lot of image processing libraries to add image processing capabilities to digital images. Some of the most common image processing libraries are OpenCV, Python Imaging Library, PIL, Scikit Image Pillow. However, in this tutorial, we are only focusing on Pillow module and will try to explore various capabilities of this module. Python Pillow, a fork of PIL. Python Imaging Library, expansion of PIL, is the de facto image processing package for Python language. It incorporates lightweight image processing tools that aids in editing, creating, and saving images. Support for Python imaging library got discontinued in 2011, but a project named Pillow forked the original PIL project and added Python 3x support to it. Pillow was announced as a replacement for PIL for future usage. Pillow supports a large number of image file formats including BMP, PNG, JPEG, and TIFF. Let's go on introduction of it. Python Pillow. Python Imaging Library is a free and open source additional libraries for the Python programming language that adds support for opening, manipulating, and saving many different images files formats. It's available for Windows, Mac, OS X, and Linux. Let's go on topics: image archives, image display, image processing. Image archives. The Python imaging library is the best suited for image archival and batch processing applications. Python Pillow package can be used for creating thumbnails, converting from one format to another, and print images. And image display, you can display images using TK photo image, bitmap image, and Windows DIB interface, which can be used with Python Win and other Windows based toolkits and many other graphical users interface toolkits. For debugging purposes, there is a show method to save the image to disk, which calls the external display utility. The image processing, the Pillow library contains all the basics image processing. Functionally, you can do the image resizing, rotations, and transformation. Pillow module allows you to pull some statistics data out of image using the histogram method, which latter can be used for statistical analysis and automatic construct enhancement. Let's go on one example: opening, rotating, and display an image. For example, for import image, open image using image module and show actual image and show rotated image. For getting actual image, im.show in parenthesis actual image is this one, and the rotated images in 45 degrees is this one. Opening and displaying the image. The Pillow module provides the open and show function to read and display the image respectively. For displaying the image, Pillow first convert the image to a PNG format on Windows OS and stores it in a temporary buffer and then displays it. Therefore, due to a conversion of the image format to PNG, some properties of the original image file format might be lost, like animation. Therefore, it is advised to use this method only for test purposes. Let's go on another example. For the location of the image, if we input this format, we'll get the output in this way, which is in geeks for geeks, which is the middle. Getting information about the opened image, getting the size and the format of the image. Size attributes provides the size of the image. It returns a tuple that contains width and height. Format attributes returns the format of the image file. This is also one of the example. And let's go on another. Bands. An image can consist one or more bands of data. The Python imaging library allows you to store several bands in a single image, provided they all have the same dimensions and depth. For example, a PNG image might have R, G, B and A bands for the red, green, blue and alpha transparency values. Many operations act on each band separately. Example: histograms. It's often useful to think one each pixel as having one value per band. Modes. The mode of an image is string, which defines the type and depth of a pixel in the image. Each pixel uses the full range of the bit depth. So, a bit pixel has a range of 0 to 1 and 8-bit pixel has a range of 0 to 255 and so on. Let's go on coordinate system. The Python imaging library uses a Cartesian pixel coordinate system with 0 to 0 in the upper left corner. Note that the coordinates refer to a implied pixel corners. The center of the pixel addressed as 0 to 0 actually lies at 0.5 to 0.5, and the coordinates are usually passed to the library as two tuples x and y. Rectangles are represented as 4 tuples with the upper left corner given first. For example, a rectangular covering all of an 800 cross 600 pixel image is written as 0, 0, 800, 600. Let's move on filters for geometry operations that may map multiple input pixels to a single output pixel. The Python imaging library provides different resampling filters. For image nearest, pick one nearest pixel from the input image, ignore all other input pixels. PIL image box. Each pixel of source image contributes to 1 pixel of the destination image with identical weights. For upscaling is equivalent of nearest. This filter can only be used with a resize and thumbnails methods. In new version 3.4, PIL image bilinear. For resize, calculate the input pixel value using linear interpolation on all pixels that may contribute to the output value. For other transformations, linear interpolation over a 2x2 environment in the input image is used. For PIL image BIC, for resize, calculate the output pixel value using cubic interpolation on all pixels that may contribute to the output value. For other transformations, cubic interpolation over a 4x4 environment in the input image is used. PIL image Langjaws, calculate the output pixel value using a high quality Langjaws filter, a truncated sign on all pixels that may contribute of the output value. This filter can only be used with resize and thumbnail methods. This is all about the Python pillow and about Python imaging library.